Welcome, 7th grade. Today we compare and order rational numbers. You're going to find that we have to do a lot of converting today so that they're all the same type. You may as well want to strap on your brains because we're going to be thinking through it. Please don't make other plans. Leaving in the middle of lessons is sometimes necessary, but not good. All right, so we got to make sure we know how to go between mixed numbers and fractions. All right, 1 and 3/4, that would be 7/4. All right. Yay, triangle method. 8 times 2 is 16, plus 7 is 23. 6 times 1 plus 5, all right, is 11 over 6. 8 times 12, that's 96, 97 over 12. All right. You must know how to do this triangle method. You all showed you were pretty proficient at it. I'm happy with you. 8 weeks, good job, problem of the day. All right, learn to compare and order fractions and decimals. We know how to go between decimals and fractions and decimals. Now, we're going to compare them all. Which is greater, 7/9 or 2/9? When fractions have the same denominator, you just compare the numerators. Because this is saying we have 7 pieces that are 9th size. This is saying we have 2 pieces that are 9th size. All right? 7 of those pieces is greater than 2 of those pieces. We can put our symbol right there. Okay? Because 7 is greater than 2. It's like saying 7/9 compared to 2/9. It is obvious which one is bigger and greater. So compare these. When they do not have common denominators, you want to get common denominators. All right? You can do this by either taking 9 over 9. That's 40 over 72. This side times 8 over 8. So the 8 over 8, that's a fancy one. The 9 over 9, that's a fancy one. There are ways of expanding fractions. All right, so that would be 56. This would be 72. We now have common denominators, and we can realize 56 over 72 is there. Now, not every time are you going to use just the denominator. Sometimes you can use a smaller number to get a least common denominator. This time, 72 is the smallest common denominator that both numbers will go into, and we got our answer of a greater than symbol. Let's make sure that's what they got. All right? The LCM is 72, so we have to figure out what turns 7/9 to get 72 on the bottom. Oh, that's times 8 over 8. 5/8, oh, that's times 9 over 9, and we get 45 over 72. And we compare the numerators then. We see 56 over 72 is greater, so 7/9, and we can put that in there. Now with this one, remember, a number with negative signs, if the number is actually bigger, it's smaller, because remember, it's further from 0. So now I'm looking at the 5, I'm looking at the 7. What is a small number, a least common denominator for both of them? I want to get to 35 because 7 and 5 will go in there. So 5 over 5 on this side, because that'll get my 7 to 35, which is a least common denominator. 5 times 3 is 15. I got to remember it's negative. That's an important part. Over here, I do 7 over 7 because 7 times 5 will get me 35 on the bottom. Remember, just expanding fraction. 7 times 2 will get me 14. And I got to remember, negative. All right? Now, since it is negative, we've got to think, oh, that negative 15, that would be further from 0, so it's smaller, and we get a less than symbol. Okay? Getting common denominators, remembering when things are negative, how we have to look at them. All right, so their work then. We took it times 7 over 7, negative 14 over 35. We took it times 5 over 5, negative 15 over 35. We compared those two. Negative 14 over 35 is greater than negative 15. That is what we came up with as well. All right, here we have 6 and 8. This is the first time we're really going to see a number smaller. I think 6 will go into 24. I think 8 will go into 24. They both will do that. 24 is my least common denominator. That's what I want to work with. Now you can write it all out and do least common denominator, or you can use your multiplication facts and realize that. All right? 3 over 3. Now I could use 6 over 6 and get a bigger number, but I like to keep my numbers small if I can. 3 times 8, that gives me 24. I know 6 will go into 24, so I can do something different over there. 3 times 7, that gives me 21. Now, that was just a fancy 1, so it's not really changing anything. So I'll take this side times a fancy 1. All right. Oh, 4 times 6, that is 24. 4 times 5, that is 20. All right. When we do that, then, we can compare them and see that 21 over 24 is greater. 7/8 is my greater number. Remember, fancy 1, fancy 1. We're not really changing anything. We're just expanding the fractions, making them look different. They still mean the same things. All right. 48 over 48. Notice they went 8 times 8 because they just took this 8 over here and went 8 over 8. Let's see if we get the same result. They just did, they took this and 6 over 6. All right. So they did that and they get 42 over 48. Now, when they compare these, they realize 42 over 48 is larger. Hey, they still said 7/8 that I'm circling down here is greater. It does not matter what number you go to. We could take them both times a number that would get a much bigger denominator. I don't see the need. I used the LCM. That was 24. They made a mistake and didn't realize that. All right, now on this one, 8. So 8 over 8. All right, that would be 40 over 56. And it's important to remember it's negative. 7 comes here, so 7 over 7. All right. This is a way to get a common denominator. It's the simplest way without any thought. The least common denominator is simpler, but in this case, they happen to be the same thing. 7 times 8 is 56. And 7 times 6 is 42. And important to remember it's negative. So now, the one that is further away from 0, the negative 42, that is actually the smaller one. So negative 5/7 is greater. This one is greater because it's closer to 0. All right. So they do that and they get their numbers. Hey, those are the numbers we had. And they saw the same thing. Negative 5/7 is greater. All right. Or you could say negative 6/8 is less. We put a less than symbol in there. You're going to have to think about negatives and comparing them. Now, to compare decimals, line up the decimal points and compare digits from left to right until you find the place where the digits are different. All right, I say it a little bit different way. Line them up. I'm going to move this one real quick. 0.425. Now, Lily, once we line up those decimals, we can just treat this like two numbers. 427. 425. Which one's bigger? 427 is bigger. I know that one's bigger, so I can put the greater than symbol in there. If you line up the decimals, you can compare them like they are regular, plain old numbers. So line up those decimals. We did that. Compare the thousands. They're different. Everything before that's the same. So the first thing that's different, we compare that. Oh, 7 is greater than 5. So, since that is the case, oh, feathers, we see, hey, there's that greater than symbol. Okay. Over here, 0.73. But notice the 3, that line over it means repeating. So 0.73. Now, normally we just put a placeholder here, a nice 0, and we compare. But we cannot do that this time because, oh yeah, this 3, that's repeating. So to fill in the spot, we have to put a 3 there. Now that the decimals are lined up, 7s are the same, 3s are the same. Oh, 4. 3 is smaller, 4 is bigger. I get a less than symbol in there. Or the way I like to look at it, 734, 733. I just look at it as if they're regular numbers. Once the decimals are lined up, 734 is bigger, so we get our less than symbol. All right. That's the first one that's different. They got that less than symbol as well. All right. Here, we line them up. I'm going to move this one, 0.538. Now I look at them, 535. Look at this one, 538. I know 535 is smaller, so I put my less than symbol. They're going to show you the same result. Let's do it. They line them up. They're comparing everything. They see the difference in the thousands first. So we know 5 is less than 8. So we get our less than symbol. Okay? Hopefully you're getting pretty good at this. Notice here's another repeating one. So we can't just fill in with zeros or anything else. We must fill in with 3s. So 0.333. Now, it makes no more sense to continue all the way out because we have the same number of place values. If I look at this number, 334, 333, I see it needs to be a less than symbol because this one is smaller. Okay. All right. And we move on. A rational number is a number that can be written as a fraction with integers for its numerator and denominator. That means whole numbers or negative whole numbers. When rational numbers are written in a variety of forms, you can compare all the numbers by writing them all in the same form. You've done this before. The values of a number line increase as you move from left to right. Okay. Now, I see I'm going to have to compare all these things. 0.93, 0.9, and 4/5. 1 is a fraction, 2 are decimals. I would say we turn them all into decimals. So I would do 4 divided by 5. Don't forget your decimal here. Put it up top. 0.8. Okay, so now, from least to greatest. So now I got to compare them. 0.93, 0.9, 0.8. When I'm comparing, I really like them all to be the same so I can just look at them like they're regular numbers. So I put my placeholder there. There's no repeating symbol, so I can just put the placeholder. Oh, I think 0.93, that's the biggest. Then 0.8, that is the least. And this one is the middle one then. Okay? Biggest, middle, least. Oh. Let's see if they see it the same way. Write them all as decimals. So there we go. And there we go. Graph the numbers on a number line. We do that. And yes, we got them correct. All right, compare the decimals in order. There they are. 0.8, 0.9, 0.93. We did it right. Now this next one, again, I see 1 that is a fraction, 2 that are decimals, so I'm going to make them all into decimals. We could make them all into fractions and get common denominators, but many times that's a lot more work. So 3 divided by 5, sorry about the ugly, ugly handwriting. That's a 0, that's a 6. Oh, 0.6, 0.84, and 0.7. I like to have my placeholders so I can compare them like numbers. Oh, 60, that's the smallest one. Least. 84, that is the biggest one. And 70, if you just see that, that's the middle one. So 0.6, 0.7, 0.84. That will be our order. Let's see if they agree and put it the same way. Today's stuff is rehashing or recapturing what we've done before, but now we're using it in new ways. So you've done all this, now you got to put it all together. All right, there we go, and there we go. I think you're ready. You must think before you act, because you have to approach situations differently. That's the part that scares me, thinking before you act. You can do it, we just like to rush into things.